Hello, everyone. Welcome to Test-Driven Development. So for this one, I'm looking around the room. I don't think we're super solid on testing syntax, so this one isn't going to be so much of a follow-along as a purposeful survey. So maybe you can think about how TDD fits into the toolbox a little bit better. Cool. Let's pull up a whiteboard. And look at it. Okay, so with TDD, test-driven development. So with test-driven development, our tests are driving the development process. They're not merely present in it. So before the phrase TDD was coined, this was broadly called test first. So instead of working and then writing tests to see if our work did what we thought it should do, we go, all right, what would that test that I write be? How would I know that I'm done? Why can't I write that first and then make the test pass? So it's a kind of inversion of this. And it's actually even more powerful than that. It's funny because I just got an argument on the internet about this an hour ago. This is an example of building quality in. So those of you who've been in the Agile chats talk about build quality in. Test last is a form of inspection. So we build something and then we inspect it to see that it does what we want. Who can tell me what the problem with that is? What happens when we inspect and use that as our driver of quality? Interesting. How does inspection improve something?
It doesn't.
It doesn't.
It's just checking it isn't broken.
Yeah. The quality was either there or it wasn't at the point you inspected it. So you can't improve the quality of anything by inspecting it. You can find out that it lacks quality and then send it back to be built again. Then what do you have to do?
Start over and repeat the process and hopefully hit it.
Yep, fingers crossed. Goes back to QA again. Maybe it's the same fucking bug that's there. It's a different QA person looking at it. Maybe, fingers crossed they don't find it. So we call that guess and check. And to put this in the Agile timeline, this goes back to Deming and Jurin and the auto folks from 50s, 60s, 70s, 80s. So Deming's third point, in fact, cease dependence on inspection to achieve quality. Eliminate the need for massive inspection by building quality into the product in the first place. So this goes back a ways. So the guy who got mad at me when I quoted this was like, it's very rude to imply that somebody else's engineers suck. And that's not at all what this is. It's not about well, maybe just hire better engineers in the first place who don't do stuff with so much bugs, dummy. We can build quality in through all kinds of tools. Writing the test first, knowing what the outcome should be, and using that as a feedback loop. What is this thing that the QA engineer does to uncover these bugs? Why can't we just have a computer do that while we're building the thing? Interesting. So TDD is a way to build quality in. Also, pair programming. If you're pairing, that's 2 eyes and brains working on the code. In addition to all the benefits that we've talked about with like rich brain and linear brain and that kind of thing, that's also someone who can go, oh, whoa, 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 nope, that's not gonna work. It'll look like it's gonna work, but it's totally not, because that's one more person who can find that. So pairing is a way to build quality into the process. Pull requests. So as something is coming into the code base as part of the development process, you get another developer, another 2 developers, every developer on the team, whatever like the criteria is, you get them to get a pair of eyes on it, or 3. Lots of different tools. And then like we have things like CI, continuous integration. So when you pull request something, you have an automated suite of tests that tell you if you broke anything that was already working. These are ways that we build quality into software, not just inspect to see whether or not it's there. Has nothing to do with being a good engineer or a bad engineer or anything like that. Everybody makes mistakes. Things like this help you catch the mistakes before you imagine that your work is done. Questions about this idea?
I feel like that was deliberate use of imagine that your work is done. It's a state of mind.
Yes. And I was talking about that with Elise this morning. I got some super bad news recently. Like everybody's alive, but very disappointing. And there's like a lot of reasons that I should have been very disappointed about it. But like my mindset shift I was trying to make was nothing changed. I didn't have something and then I lost something. I never had something that I imagined that I have. And now I know that. That's actually an improvement. Like I went from ignorance to knowledge, not having something to losing something. The entire thing happened inside my head. So similar kind of thing here. Other questions, comments, thoughts? Cool. So let's talk more specifically about how TDD fits into all of this. So first thing you need to do is determine acceptance criteria. This idea is that what will I do when this is over that lets me know that I'm done? So this could be steps that you follow. I log in and then I go to this page and then I go to this page and then I click on this thing and I type the following thing and then I hit enter and then this thing shows up. That's acceptance criteria. I know the feature works when those things happen. You can also like include your definition of done for anybody who's in that lesson. So needs to be styled, needs to be mobile responsive, needs to be AA WCAG accessibility, needs to load in under a second. Any of these things that like fall under your general definition of done, they're not features, they're part of everything. And so like that might be part of your acceptance criteria also. You might have one for happy path and sad path. Happy path and sad path are everything goes correctly, what happens? Sad path is somebody does something wrong, what happens? So like this is testing out, does the error message show up correctly? Like, does the thing that I expect happen rather than just breaking the app? Or I don't know, we hope nobody does that. But you figure out like a reasonable number of happy paths and sad paths. Cool. So we do this at the feature level, like for our thin vertical slices. That's one level of loop. So we'll say that that's this outer loop. Within that loop, we often have smaller loops. In the process of getting these things done, we need to write functions. Okay, how do you know that function works? Well, I know it works when I give it these inputs, I expect this thing to return from it. But every function needs to be refactored. Every function needs to be performant. I need to handle any errors that come back from that. So it's this exact same thing. It fractals all the way in. Depending on how complicated the app is, these loops can have loops. And the idea is that when all the little tiny loops pass and all the medium loops pass, the big loop passes. You've built a quality feature. Those different levels of loops, they go by some different names. But generally speaking, they're represented by a pyramid. End-to-end integration and unit is the most common. I've seen this with 7, 8 different levels in this pyramid. It kind of doesn't matter. Like, the idea is that up top, you're replicating what users do. Down low, you're talking about what the system does. So this is customer facing, this is computer facing. These tend to run slower and they're more complicated, so you do fewer of them. These are super predictable and run fast as hell, so you do a lot of them. Integration is combinations of units. A few different ways you can think of this, but at the highest level, what is my thin vertical slice supposed to do? At the smallest level, what are like the functions or the classes supposed to do? And they're called units because they're functions in functional programming and JavaScript and Ruby and OOP stuff. You're testing classes. If I call this method on this class, does the state of the object change the way that I think it does? Whatever like the fundamental piece of your application is, smallest level you can think of, that's a unit. And then integrations test combinations of units. And then as we get up to the top of this, it's like operating a browser. I have no idea if this is a Vue app, an Angular app, a vanilla app, native mobile app. It doesn't matter. Steps would be the same either way. So that's how TDD kind of like breaks down. Ask me some questions about that.
So that'd be like units, a function, integrations, a component, and ETs, the app?
Yep. Good summary. Now, you'll hear the kind of test that I'm going to show you first, like the big outer loop. It's even in like their docs. They call those integration tests. You'll also hear people refer to component tests as unit tests. The terminology on this is a little bit loosey-goosey. I wouldn't lose any sleep over it. Just like as you decompose something down, keeping in mind something like app component method or function or something that's a pretty good way to think of it.
So is this what you would use it's Jest, right? The testing framework.
Hmm?
Can that
So
be
Jest,
any of them?
so Jest is a test runner. Let's talk about that a bit. Jest, probably about here to here on this. There's another tool that I'm going to show you some. I'm going to show you some Jest today. I'm also going to show you some Cypress. Cypress is kind of more here to here. Cypress is browser automation. So it tells Chrome or Firefox, go to this website, click this link, tell me what's in the URL, that kind of stuff. Jest like loads up functions and passes variables into them and tells you what the output was. So, and then like Jest is really like kind of a reimagining of some other tools, Mocha and Chai. And there's so many of these. Jasmine. I did Jasmine tests for a really long time. QUnit.
Someone likes their tea.
What was that?
I said someone likes their tea.
No kidding. Well, it's because it's T for testing. So a whole bunch of things kind of in this area. Over here, like the two main contenders, well, like in this one's exclusively, and then Selenium. Selenium is another browser automation tool, super rich, full-featured, obnoxious as fuck to write tests in. So Cypress is trying to like knock it out of the #1 slot, and I'm all in on Cypress. I think Cypress rocks. The one thing that Selenium still has that Cypress really just kind of doesn't is robust cross-browser testing. So Selenium, you can say, all right, I have this test suite, and it needs to work on the following the last 3 versions of these 6 browsers, and it'll run all of those tests for you. Cypress doesn't quite have that yet. It's like, it can do Chrome, it can do Firefox, and it can do Electron, which is Chrome. And that's it. But like Edge is coming and a couple of other things. These are also way less like different programming languages and way more like different expressions of very similar ideas. There's like 2 really common types of testing patterns you see kind of down here. And there's really just these 2 tools up here. And like, there's a lot of shared vocabulary between all of them. Like Cypress is literally like parts of Mocha and Chai under the hood. So even though like it's very easy to get overwhelmed by the volume of testing tools out there, they aren't actually all that different between them. Other questions about how TDD fits in?
Industry-wise, is that like its own job, like one position, or is that what everyone does?
It is in a lot of places. So like Miriam, for example, like when she started at C-SPAN, like most of her duties were writing Cypress tests. And then over time, she like kind of grew into some of the other stuff in the code base. There are teams where they just have like dedicated testers. All of these tools I would classify as developer tests. And specifically a developer test is like, I am using these to help me write better code. This is part of the build quality in thing. And so that shouldn't be a telephone game thing with like 2 different people. It is plenty of places, but it shouldn't be. And if you want to like learn more about that topic and just overall, this is the best book on testing I've ever seen in my life. It is so fucking good. It's like, yeah, not short, but if you want to get carved out of wood on like testing philosophy, like it's all in here. Developer Testing by Alexander Tarlinder. Other questions about how this all fits in? Cool. So we've talked a little bit about building quality in versus guess and check, and how TDD is a tool for us to help build quality into applications. It's not just arbitrarily doing something in a different order. It's preventing this guess and check loop that it's very easy to get in. If we know what winning looks like, and we should before we start, let's put that into the code. And we talked about how in practice, we do that at high levels that like mimic how a user is using your application. And then we do smaller and smaller and smaller loops of these exact same things. What will done look like? How do I know I'm done writing this function? How do I know I'm done writing this component? How do I know I'm done writing this feature? We express that in code. Any other things that need to be present for our app to be done, we try to express those too. And we try to capture the steps for common scenarios. And then down at the smallest level, these like little unit tests, I go, okay, well, this thing takes in 2 numbers. What happens if it doesn't get a number? What kind of error does it throw? You might say, okay, what if it is a number at the boundary of the biggest number that JavaScript can handle, for example? What happens if that gets passed in? Does it explode? How does it explode? Does it explode in a way that I'm expecting it to? So that's why it's wider down at the base. You tend to have more of them, and they tend to be a little bit more exhaustive. But never forget, the purpose of all of this stuff is making good apps. It's not just writing tests to write tests. And one of the reasons that we don't teach TDD in the program, why this is a hard thing to fit into a program like this, is it's all fundamentally about prediction. And it's hard to predict what an app should be, what functions should output until like you've written a lot of them. So I'd say like by the end of the program, like most people are ready to at least start scratching it, like at this a little bit. But you should not feel bad if like you can't predict what the output of a function should be when you're done, when you're getting started. All right. So now I want to show you what this thing looks like in practice. Again, you don't need to follow along with this. I'm going to try to go kind of quickly because I want you to see what this flow kind of feels like more than like focusing on testing syntax, because like there's a fair amount of it, and like we have videos on it. We can talk about testing syntax some other time, but that's its own thing, and you need to have that kind of under your fingers for the speed of this to unlock. Otherwise, it just feels very frustrating that like you spend almost no time writing code and all this time trying to like fuck with syntax things. All right, so I'm going to do this in Vue because Vue bundles Cypress and Jest together, so it's just easier to demonstrate this. This stuff applies to anything though. So if I do, let's see, Vue create TDD practice, npm install at vue/CLI.
So quick question.
Mhm.
What's the best way to implement like testing into thin vertical slices where you won't get like spending hours on testing and then, oh shit, I need to get back to my project?
Get fast at writing tests. Like, you want the test to be something you don't have to spend a whole lot of mental energy on, at least the syntax of it, which is one of the reasons that this is not that common a practice, because most people are not very good at testing syntax. So once that's under your fingers, it doesn't take a ton more time to write the test than it does to look at the console log. Because here's the thing, you're already doing some kind of test-driven development. You're already going like, all right, and then once I see this thing on the page, I know I'm done. The only thing we're doing differently is making computer check that instead of like you by hand. All right, let's do no. Yes, yes, yes. All right, so it's scaffolding out a view app for me. This is just like Rails new.
So another idea that I had, what if you could make or if this exists, if you could have a library of tests, like abstracted tests that you could import that could like help you with testing and then take it to the next level and help you with refactoring. Is that a thing?
The thing you're describing is like basically what Chai is, and like just brought in a lot of that too, where they're trying to make the syntax as like unambiguous and simple as possible. So you get like a lot of testing helpers out of it. Because there was a period of time where like Mocha and Chai were insufficient for like the way that web apps were going. And so they came up with all these plugins. But then you had to know what those plugins were, and then you had to kind of configure them and tweak them. And Jest was an attempt to go, fuck it, just install Jest and you're done. You just get, it's like having Mocha and Chai with all the plugins pre-configured. So it can handle asynchronous code and all that kind of stuff. So you get a little bit of that. The refactoring thing, not possible in JavaScript, is possible in TypeScript. And like any statically typed language, you can get advice on like, don't do it that way. Because this is also part of, refactoring is also part of this testing cycle. If I can get it working, if I can get the test passing as dirty as I need to, then I can refactor the code and make it better. And all I have to do is keep it from breaking. And I get like a little warning. So there you go. All right, so we hop into this. Let's set up a server and an editor and our tests. Run test. All right, so here's Cypress. And if I run this, it's going to load up this boilerplate app and say, cool, I was able to go to the URL and it loaded up. This is the test runner. This is Cypress. So what we want to do this is the test that it just ran. It goes, okay, I went to this page and then it has I'm asserting that it has an H1 that has the following text. And if I change it to like have an exclamation point, now the test fails. So for our new features, what we want to do is say what would be there that would make us feel like it worked. So we're going to do, let's do an app that uses the Pokemon API and then shows a list of Pokemon sorted alphabetically. So this will be describe listing Pokemon. You'd say like, it shows 10, let's see, what is it? How many come back from this thing? Is it, it's API? Yeah, there we go. All right, looks like 20 of them. So it should be something like, it shows 20 Pokemon sorted alphabetically. That's our happy path. So I go to the page and I want to say something like, if I get the thing that has a like dot Pokemon, or maybe I'll call it ul.pokemon. No, I'm going to go li.pokemon. I'm going to get that, and it should have a length of 20. That's my acceptance test. I'll know this feature is done when I see that. I could also say things like, and the first one's name is whatever the fuck. You can get specific or vague. What I'd recommend is be very pragmatic about this. It's very tempting as you get into testing to turn this into like, I can prevent all problems by being super specific in my tests, and you really just can't. What you end up doing when you do that is you make these really brittle tests, and as soon as you change something for totally legit reasons, all your tests break, and you need to go fix those to match whatever your new thing is. And then your tests start not matching your expectations, they just start matching your code, and that makes them not useful. All right, so do I have a failing test? I expected undefined to have a length of 20, but got 0. All right, well, I have stated some kind of expectation. So in the red-green refactor cycle, this like TDD kind of process, one of the things I can do, and like don't underestimate it, if I get rid of all this stuff, go, all right, can I get it to pass, like by cheating? Give this a class of Pokemon. What was it called? Yep. An LI with a thing called Pokemon. Dude, didn't like something I just did. What's it mad about? Oh, I didn't put it inside of the div. Cool, I got a passing test. When we talk about red-green refactor, we went red to green. The refactoring is like making this more real. Also, the test set is supposed to list them alphabetically, so I probably need to have some guess of that. I wonder if I can compare letters directly. I don't know that I can, but if I get the first one, should, man, I don't know how to do this. Let's see. Is there a Cypress assertion? Oh, I can use match and do a regex. Match, perfect. Should match starts with, let's see. I'm kind of tying it to the implementation on this, but whatever. Starts with R, starts with, what's the, V is the last one here. W, any X, Y, or Z's, W. Weedle, so should start with W. And I could say The last one should start with W. Is there any, there's some C's, there's a B. There's a B, B. No A's on here. Cool. So let's say that should start with a B. That one should start with a W. Really, you want to like try to divorce it from the data as much as possible. And you can also do things like actually intercept the network request, so you're always getting back like a fixed number of things. So the Pokemon's name from like your little intercepted thing could be A, B, and C. And you're testing, you get 3 of them back, and the first one's A and the last one's C. So if I go back to my test runner, all right, expected that one to match B. So if I just make that one Pokemon, oh, it probably also needs me to say the rest of them. Shoot. Maybe. Oh man, shoot. Tell you what, I'm going to throw in the interceptor. Can fix that. So Cypress routes. Okay, so we need to start a server. We can say, before this even fires off, if I make a route request, like a fetch request, that's a anything with like Poke API. So what is that? And then you can say what it should respond with. So we want it to kind of match what we're getting back. So it has a results thing. And each of those results has a name, and then we're going to ignore the rest of it. Cool. And now, like in the actual app, we just make it match that. So now our test can be, should have length of 3. Should have text. Cool, I like that better anyway. All right, let's take a look at our tests. Hey, cool. So now it's, those things are showing up. We got passing test, all's right with the world. So red, green, now we got to make this real. Oh, and the other thing is that I should show these in like kind of a random order. So ultimately, we still want that. Cool. Oop. Mad about something I did. All right, we're green again. So now what I want to do is, instead of hard coding these, I want to fetch them. So maybe I say something like, I have this computed property here that returns those Pokemon as an array, and then I iterate through them. So really, I'm doing the same thing that I'm doing here. Cool, so if I do that, and then with these, I start looping over those. Like a V for Pokemon and, oh no, sorry, Jack, the plural of Pokemon is Pokemon. And then this becomes mon.name. And these have keys. Cool. So now I'm not hard coding it anymore. Still works. Maybe. Oop. Check that out. Expected to be C, but it's C and some stuff. Ah, it's because of prettier, man. So this one, like, this one took me a long time to figure out. So you see how prettier formatted this? Like, I wrote that, and then when I saved it, it changed it to that. Those new lines count as spaces. And so that's why it reads it as that. So, all right. Should include maybe? What contains. Cool, and we're green again. That's kind of what I mean. Sometimes you got to fuck with the syntax. Like, if you're not comfortable with the syntax, you end up spending all day doing that. Okay, so I've got this. Now I need that to actually like come back from a fetch request instead. So maybe I have a, this is the same thing as state in React. Okay, so I do that, and then I should temporarily see my test fail again. Cool, tests are gonna fail. And if in this mounted hook, I say fetch HTTPS, and then pokeapi.co/API/v2/Pokemon, and then parse the response, and then take that response and set this dot Pokemon equal to response dot results. Oh, it should have intercepted that though. Maybe that. Take a look at this again. Well, fuck it. I can put the actual thing in too. So I'm running this server. Maybe it needs to be before the visit happens. Why isn't it intercepting that? Hang on. I wonder what happens if I kill this and start the test over again. Still all coming back. One of the cool things about Cypress is that it is a browser, so you can like inspect stuff. Oh, what the heck in the world? Why you gotta make me look dumb in front of my friends? Why else might that be happening? All right, well, for purposes of this, I don't want to waste too much time on it. So we'll say that, get rid of that. Just go back to that. We can say the first one is Bulbasaur. Last one is Raticate. Oops. All right, we're back to green. So, but I want to sort these alphabetically. So maybe what I do is write a test for that too. So I could go to my unit test. I could mount the component that I just wrote. And I could say something like it renders a list alphabetically. And so for this one, I'm going to mount app, make this wrapper. Maybe I have something that's like is cached equals true. So maybe this fetch. Actually, shoot, that's not gonna work. Maybe this thing has an alphabetized method that's like wrapper.alphabetize. And I can take a list of things like list where I pass in that and then I expect the result of alphabetizing it to be A and Z. And so I expect wrapper.alphabetize with list to equal results. So before I write the method, I can still call it. So then to run that test, I can do something like just watch all, maybe the X just. Okay, it doesn't like the app that I'm importing. Is that what it's called? Oh, it's not in views, that's why. Fetch is not defined. Get no kidding. There, we can do that. If fetch. Because I don't want it to actually try to fetch the fucking things. Cool. Alphabetize is not a function. Now we're in business. So can I make it a function? And then maybe I need to actually call it by method. Wrapper dot property of alphabetize undefined. Okay, so I go to the view test utils. Shallow mount. Turns a wrapper. Ah, there we go. .vm. Cool. Expected all this back, got an empty array. So now if I do something like, now I just need an implementation for that. So I can do something like npm install Lodash. And then if I import sort by from Lodash FP, and then this is sort by name list return. Now I have a passing test. So I could do something now. Now that I'm confident that that works, I can say something like alphabetized or sorted Pokemon. And this is going to return this dot Pokemon, this dot alphabetize, something like that. Now this can be sorted Pokemon. Unit test pass, check in over here. Cool. Ooh, all right, that's looking sorted. So it should start with Beedrill and end with Weedle. And we're green. Big tests, little tests. And that's the general idea of this. Ask me some questions.
So you want to first cheat, like hard code, and then do it for real.
Right. And like progressively cheat also. So like some things that I'll do when I'm doing this are hard code, move it to a variable, move it to a module, like another file, something that's just outside of it, maybe like a JSON file or something, because you can fetch local files also. So something like that, then move it to a server, but still just a variable, just an array or whatever. And then move it to a database. So if you go in an order like this, it spends most of its time green. And that's part of the idea of this. And if it goes red, you know exactly what caused it. It's harder to do that the other way around. We go red, 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 red. God, I hope it finally turns green. A lot easier to figure out, like, cool. So I know what victory should look like. It should look like these things being in my HTML. All right. Any problems if I move it here? Any problems if I move it here? All these steps are so small that they're really hard to fuck up. But when you do fuck them up, you get immediate feedback. That's helpful. Other questions?
And so, seems like a big part of it is like finding a balance between not being too brittle but not being too vague.
Right. And like, that's probably more art than science. There's some really good guidelines on like things that tend to not make very good tests. But some of this stuff, you just have to have been burned by being too specific or too vague. It's a pinch the garden hose kind of thing. If you pinch it all the way, no water comes out. You don't pinch the garden hose, it just sort of dribbles out. You pinch it a little bit, flies across your lawn. Takeaways. What are some things you learned from this?
Well, something else I just thought of, what would the sad path look like?
Network's down. What happens if the network breaks? What do they see? Nothing? Or like a little thing's like, sorry, the Pokemon server seems to be down right now. That'd be the sad path for this.
Okay.
And you can fake that out with those Cypress routes. I don't know why that wasn't working, but you can say like, all right, and then when this happens, like there's a specific thing for like break the network or simulate a network breaking. So, simulate a redirect, delayed responses. What happens if it's slow? Maybe for the first 2 seconds, you see something that goes like, oh, wow, this is taking longer than we expected. Yeah, there's something in here for like just totally breaking, doing a failure. Other questions, takeaways, things you learned? Here it is, force 404. Cool. Hopefully that was useful. Hope to see some of you over at the CSS thing. Cheers.